Welcome to Geometry Pre-AP. Today we're doing a lesson on Chapter 2, Section 4 about deductive reasoning. If you want to pause the video, write down the Texas Essential Knowledge and Skills TEK, or write down some of this vocabulary that might be good for your notes. And the essential understanding question, which is given true statements, you can use deductive reasoning to make a valid conclusion. So pause the video and get this vocabulary down. Remember that we're always doing stuff with vocabulary, so it's important to have it down at the beginning of your notes. Okay, so now that you've written those down, what is deductive reasoning? Deductive reasoning is using facts, definitions, or accepted properties and different laws of logic to form a logical argument. Like we said the other day when we were talking about conditional statements, geometry is proofs. You've got to learn how to prove what you know and prove what you're doing. And that is very important in law and just doing things in general, that you have to be able to tell somebody, hey, this is what you want to do and this is why you want to do it and it's this way because of this. And so facts, definitions, accepted properties, not our opinions, just what we can prove mathematically. Okay? All right, so the law of detachment, which is it's not really a property, it's a law of logic, says that if the hypothesis of a true conditional is true, then the conclusion is true. So basically what it means, and what I've always told my students in the past, is that if you have a conditional statement like if P, then Q, so if you have something that's true, and they give you another statement that says, hey, I got another P statement that is very specific, then there is a logical conclusion that can come from that, a Q statement that follows the same pattern that your original conditional statement said. So if we go back and look at this here statement here, using the law of detachment, says, what can you conclude from the given true statements? So that's important there. They told us that these statements are true. So we have true statements. So it says, if a student gets an A on a final exam, then the student will pass the course. That's a very general if-then statement that's true. And it says, Felicia got an A on her history final exam. Well, we're looking at the conclusion now, which is this part. Then Felicia should have passed the course. And so just to go over this information so you guys can see what the stuff says. All right, so again, the student gets an A on the final exam, then the student will pass the course. Felicia got an A. Second statement matches the hypothesis from the original conditional statement, and it's true. Then we can conclude that Felicia will pass her history course. I like to tell my students that it's a very broad conditional statement to start, and then it's a very specific terminology in the hypothesis, which gives you a very specific conclusion. So maybe a definition and then a specific segment, kind of like our one-step proofs that we had on page 18 and 19 in our last packet. Okay, so here's another example. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. So that first statement's very broad. It's basically a definition of an angle bisector. So RS, a ray RS divides angle ARB so that the two angles are congruent. Well, if it's making two congruent angles, then I can say that RS must be an angle bisector. And so again, very broad statement, if-then statement, very specific hypothesis. So then we finish up with our conclusion right there, very specific. So very general. And this is the basis of using all definition, postulates, and theorems, that we learn them without any context, and then we apply that in all the stuff we do throughout geometry. So you've been using the law of detachment in the first chapter already. You just didn't know it was called that. You use it anytime you take any definitions and apply them from a very broad general definition to a very specific example. All right, if two angles are adjacent, then they share a common vertex. Angle 1 and angle 2 share a common vertex. So what can you conclude from this? And this is one that you're going to be doing, and we're going to be talking about this later on. So make sure you write your conclusion if you can make a conclusion, and then we will talk about this the next day. Pause your video while you write. Okay, so if you start a video back on, we'll get away from this problem and go to the next one. Remember to ask me a question about this one the next day. All right, so now we have our second property of logic, which is the law of syllogism. You can go home, you can talk to your parents tonight and say, hey, I learned about the law of syllogism. It has another name. It's also known as the chain rule by some. So it says, if P then Q, so we've got this first statement, if P then Q. Our second statement is, if Q then R. And our third statement is if P then R. And so what we're looking for here is actually they both have Q. Oh, you can't see that very good. So let me just go to a pen and I'll just circle that instead. So they both have Q. And so then we can take out the Q part and say that if P, then R. So if you look over at the example, if it's July, then you are on summer vacation. If you're on summer vacation, then you work at a smoothie shop. So therefore, if it is July, then you work at a smoothie shop. The difference between this one and the law of syllogism, or the law of detachment, is that in the law of syllogism, you have multiple if-thens going on, and your conclusion is an if-then. In law of detachment, you have a single if-then, you're given the if part, and your conclusion is the then part. In this one, your conclusion is an if-then statement, again, connecting the first if and the second then together. Okay, so let's get some practice on that. Make sure you get that down. This is how we prove things, because when we're proving things, we prove one step, we prove a second step, and a third step, and a fourth step, and a fifth step, and therefore from the first step we can get to the fifth step, and it all connects together by the law of syllogism. All right, so using the law of syllogism, what can you conclude from the given statement? If a figure is a square, then the figure is a rectangle. If the figure is a rectangle, then the figure has four sides. Notice here, we're looking at this is the same as this. They both share that same statement. So if we can cut those statements out, therefore, if a figure is a square, then the figure has four sides. And so that is what we're looking for at the end there. Oops, so we'll just pull these things off so you can see express. So the conclusion of the first statement is the hypothesis of the second statement, so you can use this law of syllogism to connect them all together. And here is our answer right there. If a figure is a square, then the figure has four sides. I know there's more about square that you might know, but we're just connecting just this information. We're not bringing extra information in from the outside and stuff like that. You have to be able to give that information to prove it. It's kind of like in a court case, you can't say, well, I know he's innocent, so he must be innocent. No, you have to prove these things. And so these are the connections that we're making. All right, so let's look at another one. If you do gymnastics, then you are flexible. If you do ballet, then you are flexible. So what is the conclusion that we can make using the law of syllogism? So you can pause your video and write your conclusion, then we'll start the video when you're ready to see what the real conclusion is. All right, well, if you wrote a conclusion, then you're wrong. There is no conclusion. The problem is here is that this part right here is not repeated in the right place. These are the conclusions for both. And remember, it has to be the conclusion of one and the hypothesis of the second. And since they don't overlap like this, they cannot make a conclusion from this. If you do gymnastics, you're flexible. If you do ballet, you're flexible. I mean, there's no connection. If they would have said you do gymnastics, then you're flexible. If you're flexible, then you can do ballet. So therefore, if you do gymnastics, you can do ballet. That's true. But it was not written in that kind of form. So that does not work. So no conclusion can be formed here. Not everything has a conclusion. That's why we put that in the directions. If there's a conclusion. If there's not, you have to explain to us what's wrong with this conclusion. In this case, the order's not right. Remember that for the order, we need that P, Q, Q, R, P, R. And in this one, what it looks like is P, Q, R, Q. There's no way for this word. It's a lot like the transitive property we learned in algebraic proofs. It's not in the right order. Does not work. Okay. So using the law of detachment and law of syllogism to make a conclusion from the following statements, if not possible to make a conclusion, explain to us why. So you can pause the video, you can do these two. I will be checking for the second one in your notes. The first one I will show you when you're done doing these. Okay, make sure you have these examples written down. When I check your notes, you have to have the examples written, not just the ones you do, but all the work notes. So make sure you pause your videos and you're taking good notes during this time. So if a mountain is the highest in Alaska, then it is the highest in the United States. If an Alaskan mountain is more than 20,300 feet high, then it is the highest in Alaska. Okay, so Alaska Mount McKinley is 20,320 feet high. Notice an if-then statement, kind of real general statement to start, very specific statement afterwards. Therefore, we're using law of detachment. And so we can say that Mount McKinley is the highest in the United States. Because remember what it said, highest mountain in Alaska, that's the highest in the United States. And it says in order to be the highest mountain in Alaska, you got to be more than 20,300 feet. And McKinley was higher than that. So it's kind of a little bit of a combination of syllogism and detachment together. You have this one down at the bottom to do, so make sure you have that one in your notes also. All right, so if possible, use the law of detachment to make a conclusion. If not possible to make a conclusion, explain why. So pause your video, try these two. I'll explain the first one. The second one will be for you to tell me about. Okay, the first one says if a rectangle has side lengths of 3 centimeters and 4 centimeters, then it has an area of 12 centimeters squared. Rectangle ABCD has an area of 12 centimeters squared. Okay. If you think that it has to have the dimensions of 3 and 4, because 3 times 4 would give you the area 12, and so if a rectangle has 12 centimeters area, then it has to be 3 and 4, you are wrong. Because we don't know. Its dimensions could be 6 centimeters by 2 centimeters, and 6 times 2 is also 12. So this is my way of showing that it is false. All I have to do is give one counterexample, and this is my counterexample. I have a 2 by 6 centimeter, which is still an area 12, which proves that it doesn't have to have a 3 by 4. So number 2 will be yours to make sure you do. Look at it carefully, make sure you make a good conclusion. All right, so now here's another set of problems. So if possible, use the law of syllogism to make a conclusion. If not possible, to make a conclusion, explain why. So pause video, do 3 and 4. I will show you 3 so that maybe it'll help you to get 4. So pause your video and then turn on when you're ready to hear my explanation for 3. Okay, law of syllogism. So if a whole number ends in 6, then it's divisible by 2. If a whole number ends in 4, then it's divisible by 2. So the conclusion should be none. It's not possible to make a conclusion because the order is not correct for the law of syllogism. It would have to be P, Q, Q, R, P, R. And they're both ending in that exact same little divisible by 2. So there's no true connection there. So we got to watch out for things like that. That's a way to get us tricked in there. Yes, they're both divisible by 2. That doesn't give us any conclusion that helps us do anything. All right, so watch out for that. It's that order that makes the most difference. Watch out for read your number 4 very carefully if you haven't done that already. And if you are not sure about that, make sure you ask in class the next day. All right, so as you're doing these problems, make sure you have your examples done. Have questions written down that you want to ask when you come to class, because if you don't write them down, you won't remember when it's time to come to class. I will check these notes, and I will ask to see if you need any clarification on the problems. Have a good night.